So, today we're going to be vocab heavy. So today we're going to be learning about and applying solid vocabulary. Vocabulary dealing with three-dimensional shapes. So we're going to learn and apply solid vocabulary. So what is a solid? The first thing is a solid is any three-dimensional object. Any three-dimensional object. And the nature of three-dimensional objects is that you can touch it, you can hold it, it's got depth, it's got width, etc. So we also classify different types. When we start to clarify and classify these, polyhedron have some special things. So number one, they do not have curves. No curves. No curves. Like this cylinder over here has a curve. Another thing that's true, and it's actually true for both of these, this here is a closed object. In other words, if there's a lid on the box, you put it on it. So there is no open space that gets you inside. So we call that closed. Next, what's true about every single one of these, and we're going to call them faces as we define. These faces, or the face that's on the bottom, this face here, or the face in the front right there. So what are all these shapes? All the faces are polygons. In other words, no circles, etc. Nothing's crossing. So these are the key things about polyhedrons. Polyhedrons, polygons. No curves, they're closed. And all these guys over here, turns out these guys can be open, they can be closed. And these ones are ones we're going to talk about today, but there's obviously an infinite number of things that we aren't going to touch upon. All right, so parts of the solid. There's lots of vocabulary. There's a lot of overlapping vocabulary. There's some vocabulary that applies to a prism, that doesn't apply to a pyramid, etc. All right, so let's get into it. First off, a prism. A prism. So I think the key thing about a prism is, number one, that it is a polyhedron. It has parallel bases. The W with the slash means with. It has parallel bases and rectangles for lateral faces. I know, it's such a crazy definition. Lateral faces. So there's some parallel action going on. There are lots of rectangles going on, and there is something called lateral faces. So all these vocabulary, polyhedron, bases, lateral, faces, oh jolly. So let's get some things clear. Okay, first off, a face. A face. A face is any polygon. And it's hard to identify the faces, but notice that this in the front is a face. So if I were just to highlight it a little bit, that's one face. Another face would be this rectangle right here. That's a face as well. So any of these guys are called faces. Sometimes we say, oh, it's the side of the box or the side of the barn. Okay, kind of like that. The side of the house, you're playing ball on the side of the house. So think of it as the sides. And in this case, notice how many faces we have. We have one in the front, two in the back, so 2 total, and then 5 all the way around. So this one has 7 faces. This one over here has 1, 2, top, bottom, and then 3 around, so that has 5 faces. Okay. Now a base, and Prisms always have two bases. Prisms always have two bases. They are congruent, they are parallel, and their faces. So, if I were to look at this first prism, the base would be this guy in the front. That's a base. And then this guy in the very back is also a base. The front and the back. Not because they're front and back. That doesn't make it a base. What makes it a base is that they're both the same shape, as we see here. This is a pentagon, and in the back is a pentagon. They're the same shape, same size. They're congruent. They're parallel as well, kind of like the front door and back door of a barn. All right, so that's what makes a base in a prism. Parallel, congruent, and their faces. Over here, which one are my bases? So in this case, here is a base, and here is a base. And of course, they are parallel and congruent. Base there, and base there. Okay. So, the other type of face we have is called a lateral face. And the only thing about this is once you find the bases, everything else are the lateral faces. They're the non-bases. And by the way, in a prism, they're always rectangles. In a prism, they are always rectangles. Okay, so far, bases are congruent and parallel faces. Lateral faces are everything else, and in prisms, they're always rectangle. So, what are the other components? Well, let's start with a simple one-dimensional object, a vertex. A vertex is just every corner. And in this case, I have 5 up here, and I have 5 back here. There we go. So in other words, they are the corners. And by the way, they're just one-dimensional, so it's a point. A vertex. And lastly, we're going to talk about edges. And the edges are pretty much the frame that you draw. So every single one of these black lines that I originally drew, every single one of these is an edge. Every single one of these is an edge. So these are the segments connecting the vertices. So to repeat, altitude is going to be my distance between the bases. In this case, it's front-back, and altitude is top-bottom in this case. Find the bases. So in a prism, the bases tell you everything. The bases are congruent and parallel, so therefore I know what the altitude is between them. If I know what the bases are, the non-bases are my lateral faces. I also know my lateral edges based on the bases because they connect the base. So again, in a prism, the most important thing are the two bases, parallel and congruent. When we name these, what we name these by is, this whole thing is a prism. Why? Because it has parallel and congruent bases. And we always define the prism by the name of its base. By the name of its base. So in this case, my base here up front is a hexagon. So we call this that's not a hexagon. It is a pentagon, like the pentagon outside of DC. So this one is called a pentagonal, or better yet, pentagonal prism. And this guy over here is a prism, clearly, and its base name is a triangle, So we call it a triangular prism. So a pyramid is a polyhedron with one base, and lateral sides or lateral faces with, so the triangular lateral faces. Notice they're all triangles. And clearly, we see that all these triangles meet at one point. And because these pyramids are most commonly set upright like this, where the base is on the bottom, it doesn't always have to be like that. Just like a cone can be turned around, a pyramid can be on its side or something like that. All right, so all of these have special names. This first part right here, this one right here, this is called the vertex of the pyramid. That's the vertex of the pyramid, here and here. It's true, these other ones, I'm highlighting them here, is these are also called, each one is a vertex, but it's not the vertex of the pyramid. It's just a vertex in the pyramid. So those don't have special names necessarily, but the vertex of the pyramid is where the pyramid meets. All right. The same thing applies for all these other ones here. So an edge is any of these black segments that you connect each vertex. All of these, it's essentially the frame. Those are your edges. Lateral faces are all triangles, so you might want to make note of that. These are all triangles in a pyramid. In a prism, they're rectangles. Lateral edges are the ones that connect, so I'll clarify this. They connect the base to the vertex. They connect the base to the vertex. And the vertex of the pyramid is the distance. Let's try that again. I meant to say altitude. The altitude is the distance from the vertex to the base. Again, when I'm saying the vertex of the pyramid, I'm talking about the high point. So this here would be from this point down to here, about. And it's always a right angle, and that is my altitude. And another way to consider it is you're standing here, and you drop a line down the center into the pyramid. That would be my altitude. And the same thing applies here. My altitude goes from here all the way down into the center there. It doesn't always have to be center. If the pyramid is leaning, then that's a different situation.